So let's look at number 1 together. What pattern did you notice?
When I'm lined up by 2 multiply. Yeah, multiply by 2. Multiply by 2.
Okay, so be careful. I am now hearing multiply by 2, but y'all started to say going up by 2, right? If you say something's going up, are you multiplying? You're adding, right? We need to be careful about that mathematical language. But you identified the fact that we're multiplying by 2. Is that what's happening every time?
Yes, sir.
So then A would be
64.
B
128.
and C.
256.
Okay. So what type of sequence is this?
Arithmetic.
It's arithmetic?
Geometric.
Oh yeah, 2. Yeah,
Geometric is
geometric.
multiplicative, right? This is why we want to pay attention to things. And notice the shorthand notes are still over there about a geometric sequence as a multiplicative rate of change. Now this is an important detail that I want to make sure that you're aware of, because this can actually help you when it's more difficult, right? It should be pretty easy to see when you're multiplying by 2. Is that safe to say?
Yes.
Okay, but sometimes it's not as easy to see that. That's why I want to remind you, if it is a multiplicative rate of change, what do we call a multiplicative rate of change?
The slope.
No.
Common ratio.
Common ratio. A multiplicative rate of change is called a common ratio. And how do we calculate a common ratio? First off, it's a common ratio, so we have a ratio, right?
2.
Oh man.
Anyone remember what C and P stand for?
As a run.
No.
Oh.
The current and previous.
Right. C was my f of n, my current value. P was my f of n minus 1, or my previous value. Right? So let's say I'm looking at this 4 here. That's current. What is previous to that 4?
3. 2. What 2?
2. And what is 4 to 2?
8. 2.
That's a 2, isn't it? Or 2
Oh,
to 1?
Yeah.
And hey, look, what am I repeatedly multiplying by?
2.
2. Let's say I look at this 32. What is previous to that 32?
8. 16.
16. What is 32 divided by 16?
2.
Notice how that ratio is the same. It is common. And again, that ratio is what I'm repeatedly multiplying by. That's important because your rate of change defines that equation a whole lot. Which I know that's what part of it, or that's what a lot of us are struggling with, but we need to make sense out of this problem, right? If I'm going to write this equation, how would I start my equation off?
F of n
Okay?
times 2.
Like that?
Plus 1. Minus 1.
Doesn't f of n need to equal something?
It is 2.
N is 2? I think n is only 2 here.
Yeah.
Right? N is my input, f of n is my output.
Oh.
So notice, if I have n right here, I just said it, n is my input, the whole thing, f of n is my
output.
Now notice how I'm saying then that my output is equal to something. If things are equal, that means they are the same. So what should the output be the same as?
The input.
And the output should be the same as the input?
It's the, whatever it's equal to.
Okay, it should be whatever it's equal to, but should the output equal an output or should it equal an input?
Output.
It should be equal to an output. Well, let's look up here. What output do I start with?
2.
Don't I start with a 2?
Mm-hmm. Do start with a 2.
And what am I doing to that 2?
Multiply by 2.
Okay, see, those are things we want to pay attention to. I'm repeatedly multiplying by 2. Well, mathematically, how do I show repeated multiplication?
Exponent.
With an exponent. What does that exponent need to be, though?
A 2.
No. Because if I put an exponent of 2, that means I'm only multiplying by 2 how many times? Twice. Am I only multiplying by 2 times?
8. Maybe 8.
Well, you're talking about because of this 8 right here?
Yeah.
But that's only 8 times. You tell me it can't be less and it can't be more?
It could be a variable.
Could it be anything?
N.
So
Yeah.
to represent the fact that it can change, it needs to be an n, right? Still one small mistake so far. This equation would not work. For instance,
Minus 1?
y minus 1?
I don't know, I just remember minus 1.
That happens a lot. Well, but let's look at the original equation that we had. F of n equals 2 times 2 to the n. If I'm looking at f of 3, that means I'm looking at the third term, right? What's the output for the third term?
8.
It's 8, right? So be 2 times 2 to the third. 2 to the third is 8. Is that what the output's supposed to be? No, that's the fourth term, right? So that means I multiplied by 2 one too many times. So I had to take 1 away. Right? The idea is that I was multiplying by 2 one too many times. I have 2 to the third. So I'm multiplying by 3 extra 2's. I only needed 2 extra 2's. I needed 1 less 2. So it's n minus 1. Another part of that is that this 2 was which term? First, right? Let's say I started at this 8, because you can write it with different things. But let's say I started at that 8 then. In this case, f of n would equal 8, right? That's where I'm starting. What am I doing to that 8?
Times 2.
Still multiplying by 2. Because I'm repeatedly multiplying, I need
Variable.
a variable,
Minus 1.
variable.
N.
How do I show I'm repeatedly multiplying?
A variable. Well,
A
it's
variable
not- it's
shows,
not-
there you go. A variable shows that it's changing, but an exponent shows I'm repeatedly multiplying, right? But because I started at 8, it needs to be n minus what?
1.
Nope. Because I started at 8, it needs to be n minus
3.
yes. I don't need to multiply by that 2 3 whole times. Because I started at the third term. Right? When I started at 2, the first term I did n minus 1. When I started at 8,
I get what you're saying.
my third term I had to do n minus 3. I don't need to multiply by 2 3 whole times. Okay. Any questions about that before we move on to number 2? Alright, speak now, forever hold your peace. So what's happening in number 2?
Subtracting 16.
Subtracting 16. Does that work all the way through?
Yes, sir.
So what is A?
Two,
My paper goes.
And then,
negative 14,
then,
negative 30,
then,
negative 46.
right? Once you notice it's repeatedly taking away 16, it's pretty straightforward there. Yes, ma'am? And can you grab that box as well? The relay MP, thank you. So we're repeatedly taking away 16 every time. So what type of sequence is this? Arithmetic. Now arithmetic has what type of rate of change?
A slope.
It can be called a slope, but it's an additive rate of change, right?
Common difference.
Or call it
Yeah.
common difference, right? So an additive rate of change. Now this is the point I'm trying to make though. It says additive rate of change, but we're subtracting.
Adding negative 16.
Okay, so we want to recognize that detail that subtracting is equivalent to adding a negative, right?
So,
Thank you.
So division be geometric.
So similar to the idea that subtraction is adding a negative, division could be multiplying by the reciprocal, right? So notice like dividing by 2, that's 2 divided by 1, right?
Yeah, that's multiple.
So that would be the equivalent to multiplying
2 minus.
by the fraction of 1/2. So instead of talking about division, we would use multiplication by the reciprocal. So that's a good question though. But additive rates of change, notice that's called a slope or a common difference, and that's what we're going to look at right now. Because where a multiplicative rate of change was a common ratio of current divided by previous, a common difference would be what between the current and the previous?
Say that one more time.
The input.
So a common ratio was a ratio current to previous.
The
A
input
common
and output.
difference would be what operation between the current and the previous? Common difference. What?
Subtraction.
Subtraction, right? So let's say we look at 50. What's previous to that?
66.
What is 50 minus 66?
16.
Negative 16.
Yeah.
Negative 16. Notice we're adding a negative 16 and we're subtracting 16 every time. What about 18? What is previous to that?
34.
What is 18 minus 34?
Negative 16.
Notice this is the same thing. We want to recognize that if it is arithmetic, then it has a common difference there. So that's a difference between the current and the previous. If it is multiplicative, there's a common ratio there, a ratio between the current and the previous. These are all notes that we need to know. If you didn't know some of this, you probably should take these notes because I'm not telling you this for my own sake. Guess what? I know this. I'm trying to help you understand it. You learned it last year with me or Miss Anderson probably. If you didn't learn it last year, then we reviewed it at the beginning of this year. You got to know this stuff. It is foundational to most of what we're learning this year. Then an equation. How would we write this equation? How would it start?
66.
Yes, but there's something even before that you need to think about.
Oh, F
Thank you. F of n.
equals
16.
66.
Which one is it?
66.
Notice 2 was my starting output. 66 is my starting output, right?
Minus
And then what am I doing to that 66? I'm subtracting 16.
n time.
So like an exponent again?
Well, no.
Why not?
Well, yeah, because it's showing
Repeated.
repeated, yeah.
So the n minus 1's right there? Hold on a second. What is an exponent again? Repeated.
Multiplication.
Are we repeatedly multiplying?
No.
We're not repeatedly multiplying, so should
No,
this be as an
subtracting.
exponent? We're repeatedly subtracting, okay?
So would you put parentheses around n minus 1?
Well, not when it's an exponent. You talking about like bringing it down?
No, I was talking about when it's exponent.
Well, remember that would still be an exponent. We don't want an exponent. Now, I will say if you bring it down and put parentheses around it like there, what's happening between the minus 16 and the n minus 1?
It's happening last.
What operations
They're being
between
multiplied.
them?
Subtraction.
They're being
Multiply.
multiplied. And what is multiplication?
Addition.
Repeated addition. So we're repeatedly adding a negative 16?
No. Well, yeah.
We're not repeatedly adding a negative 16?
No.
Why not? I mean, tell me what's happening here.
Minus 16.
We're subtracting 16, right? So that multiplication is repeated addition or repeatedly adding a negative 16. What were you thinking there? Not sure?
I just shot it out.
You just shouted out something?
Yeah.
Guys, we need to have justifications and reasons. I need you to remember, like, how do we mathematically show this idea of repeated blank? How do we show repeated multiplication with an exponent? If it's an additive rate of change, how do you show repeated addition?
Multiplication.
So there it is.
Hey, you pretty smart, man.
I don't know who you're talking about.
Both of y'all.
Okay, thanks. This got a little weird, but it's fine. We appreciate it. But it's not being smart, guys. We've been doing this since the beginning of the year, and you should have done it last year. We need to recognize that if we're repeatedly adding, it's multiplication. That's it. Don't make it more difficult than that, but you also need to know that.
See, at the beginning of the year, I did not know how to do it. Now I know how to do it.
Well,
It's a lot of stuff that we did last year that I didn't know how to do, but now, yeah.
but remember, that goes along with the idea of the growth mindset that we studied at the very beginning of the year, that we spent a lot of time on, that you may not know how to do it right away, but when you work hard at it and you put the time and effort in, you can grow and get better. It's not going to say that you're going to become an expert right away or that you will ever be the topmost authority figure on it, but it does mean that if you put in the time and effort, and this is the thing I will preach till I die, that if you put in the time and effort, you can grow and get better.
It's too late to do it now. That's last year.
No, one,
We doing it again?
we're doing it again.
Yeah.
2, it'll be on your 9 weeks exam. 3, this is the foundation for a lot of what you're going to learn in Algebra 1. 2, you'll eventually have to take Algebra 2, which guess what will show back up there? Writing linear and exponential functions. So it's never too late. Learning never stops. That's why I keep trying to tell you all. That's why I also tell you that on the understanding checks, if you do poorly, that's okay, as long as you study for the test and do better on the test, then your scores will reflect that. There's a lot of people who may not realize it, but I went in, I checked your understanding checks after the test and said, hey, if you scored higher, then I rewarded that and even made notes or comments in the grade book for that. But you have to put in the time and effort to learn and grow from your mistakes. That's the point. So let's look at today's objectives and get started with today's task. So, we're going to look at our objectives. I think I might have already said that, I don't know. Sometimes I get distracted, my bad. But we're going to look at the objectives, and we're going to start 5.1, pet sitters. You should already have a copy of this. So, really quick plug, just to remind you, I'm going to be recording missing assignments over here. If your name shows up on a missing assignment, like Zay, Dewan, Tony, Amity, and RJ on 4.1 to 4.3 self-assessment, which that says redo for Dewan, but that means I never got that. That means you have 0 in the grade book for it. You don't like the grades? Huh?
Are those old?
Yes. Notice that is 5+ days late, which means you already have a minus 50%, but still a 5 out of 10 is way better than a 0 out of 10. This is 2 days late at this point, so it's 20% off. If it's turned in tomorrow, it's 3 days late, 30% off. But again, a 7 out of 10 is way better than a 0. Yeah, so you're right here, right here. Huh?
I'm at 2.
Yeah, you're on that 4.1 to 4.3 self-assessment and this notebook check that I did yesterday. Now, some of y'all have redo next to you, meaning that you turned it in, but you need to redo it. Or fix it, meaning that probably is disorganized and things like that, and it gave you feedback.
You gonna do it today?
No, I'm not doing it today.
Okay.
You can bring it to me before or after school to look at it, but on Friday there'll be a chance when y'all are doing some test corrections that I could look at it on Friday too.
You said
I'm
after
saying
school?
redo, but I threw most of all my stuff away.
That's a personal problem.
You said after school
So I had
today?
to do all that work again?
I would say, I personally, in that case, if you throw it away, I'd take the L at this point. I would make sure you never throw anything away for this class ever again.
Yeah. Oh, because I thought that was all right.
Huh?
I thought that was all right. I thought I had
No, that's algebraic connections. That's a different Zay.
When you say after
Jennings.
school, you mean like today after school too?
Tuesdays and Thursdays after school. Monday, Wednesday, Friday mornings, I'm here for tutoring, for free tutoring.
I know what you're talking about.
Okay. So, let's get started with this. So we should have 5.1 out. Oh, by the way, I gave you 5.1 to 5.4 self-assessment. That is not due anytime soon. What I've decided to start doing is I'm going to give you those self-assessments at the beginning of the set of lessons. And I'll tell you when you should reflect upon each step there so that you're not having to do it all at once. Alright, RJ, can you read our first objective for us today?
Identify values that satisfy the
Constraints.
constraints of a word.
So when we talk about constraints, we're talking about things that have maybe equations or inequalities, things that are represented or modeled with algebraic representations, right? Notice how many constraints are we looking at? If it says constraints, you may not know the exact number, but
Multiple.
it's multiple at least, right? Last unit, when we looked at equations and inequalities, at one single time, how many equations or inequalities did we always have?
More than one.
We only had one equation, or one inequality. You might have had multiple variables, but for each problem, there's only ever one equation or one inequality, right? Now we got constraints, multiple equations and multiple inequalities. That's why this unit is called systems of equations and systems of inequalities. So that's something to be aware of and be looking forward to. I don't know why we're looking through our notebook instead of paying attention to our objectives, because the objectives drive everything we should be learning out of this.
You get harder.
Okay? I will go ahead and tell you we're never going to be looking at more than 2 constraints. So we're never going to look at more than 2 inequalities or more than 2 equations, at least on assessments and things like that, but that is something to be aware of and be looking for. The next part is, CJ, can you read the next objective for us?
I can create multiple mathematical
mathematical representations to model values that satisfy the constraints of a word problem.
So this class is called Algebra IB, which means we're focusing on getting to what mathematical representations?
Mathematics.
What mathematical representations? If it's it's what?
Algebraic.
Algebraic, right? Algebra classes are focused on algebraic representations. However, that's the end goal. That's not where you necessarily need to start. What are some other mathematical representations that you can use to help you get to algebraic?
Tabular.
Tabular, graphical, pictorial, verbal. That's it, right? The algebraic representations, those are your expressions, those are your equations, those are your inequalities. And that's what we're trying to work towards. And if you see an equation right away, I will say this, equations and inequalities can make your life way easier, but you don't have to be there right away. If you don't see a way to write an equation, or you don't see a way to write an inequality, then think about a table, or think about a graph to record your thoughts and make sense out of what is happening. And this is what's happening. Let's see, Amity, can you read the first paragraph for us today?
The Martinez twins, Carlos and Clarita, are trying to find a way to make money during summer vacation. When they overhear their aunt complaining about how difficult it is to find someone to care for her pets, she will be away on a trip. Carlos and Clarita know they have found the perfect solution. Not only do they have a large unused storage shed on their property where they can house animals, they also have a spacious fenced backyard where the pets can play. Carlos and Clarita are making a list of some of the issues they need to consider as part of their business plan to care for cats and dogs while their owners are on vacation.
Perfect. So this is a legitimate thing, and this is why I want you to understand math is not to make your life harder. Math is here to help you actually make sense out of things that you could do. They want to make money. Bet. Me too, right? And so they came up with this plan of, hey, we're going to take care of pets in order to make some money. However, you can't just wake up one day and say, hey, I'm going to take care of your pet, and people drop off their pets to you, right?
They ain't gonna trust you.
They're not going to trust you unless you can show them something. That's why they have these issues that they're considering. For instance, what's this first issue that they're looking at? Space. Duan, can you read the description of space for us?
Cat pens require 6 feet of space, while dogs.
Hold on, go back to that. Does that say just 6 feet?
6 feet squared.
So that the way we would read that is 6 feet squared, or the more common way to say it is 6 square feet.
Cat pens require 6 square feet or space, while dogs require 24 square feet. Carlos and Clarita have up to 360 square feet available in the storage shed for pens and runs, while still leaving enough room to move around the cages.
Okay, so one of the things is they got to build pens, they got to build dog runs so that these animals can stay safe but move around a little bit. And so they only have 360 square feet, so they need to consider this. All right, Zay, can you read the second consideration they're looking at?
Start up the cost of Carlos and
Clarita?
Clarita plan to invest much as $2,800.
Go back to that. 2,000?
Well, not $1,200. Yeah, $1,280. They earn from their last business venture to the purchase a cat pen and dog runs. It costs $32 for each cat pen and $80 for each dog run.
Okay, so not only do they need to consider space, but they need to think about how, like, buying the things for those cat pens and dog runs. And so there's two different sets of constraints here. Notice again that word constraints from the objectives. We have to stay within these requirements. All right, but here's the next little part. Trey, can you read the next 2 paragraphs?
Of course.
That's 2 paragraphs?
I was saying of course.
Oh, okay, so where it starts with of course, get started.
Carlos and Clarita want to make as much money as possible from the business, so they are trying to determine how many of each type of pet they should plan to accommodate. They plan to charge $8 per day for boarding each cat and $20 per day for each dog.
After surveying the community regarding the pet boarding needs, Carlos and Clarita are confident that they can keep all of their boarding spaces filled for the summer.
Okay? Tony, can you read the last two paragraphs for us?
So the question is, how many of each type of pet should they prepare for? The data suggests the same number of each, perhaps 12 cats and 12 dogs. Carlos thinks they should plan for more dogs since they can charge more. Clarita thinks they should plan for more cats since they take less space and time. Therefore, they can board more. What do you think? What recommendations would you give Carlos, Clarita, and what argument would you use to convince them that your recommendation is reasonable?
So, please notice, because this is what you are about to start working on.
It's a common thing.
Can they keep more dogs and cats than they have space? No. Can they build more cat pens and dog runs than they have money?
Yeah.
They can build more cat pens and dog runs than they have money for?
Nope.
Oh, no.
No, right?
I thought you said they had.
I got you. No. So the idea is that these are constraints. These are limits on what they are able to do. And so that's what I was talking about, of like thinking about constraints here. Notice how many sets of constraints do we have?
Two. You said we'd never deal with more than two.
Right? And I will go back. I think there might be some small cases where you deal with like 3, but I will say there will be no more than 2 variables. Notice the only variables here are cats and dogs. Alright? Alright. But we have 2 constraints here that we're considering. And then the thing is, though, we don't just want to look at constraints. If they're in business, what do they want to do?
Make money.
They want to make money, right? And so they plan to charge $8 per day for the boarding each cat and $20 per day for each dog. And so whatever combination of cats and dogs they go for, they're pretty confident they'll be able to, fill their boarding space. So the question is, how many of each type of pet should they prepare for? Dad says perhaps 12 cats and dogs. Carlos thinks they should plan for more dogs. And Clarita thinks they should plan for more cats. So here's some options, some ideas to get started. But it ultimately comes up to you and your small group. What do you think? What recommendations would you give so that they can make the most money? That's what you need to do, is you need to think through what can you recommend so that they're going to make the most money. One small hint that I want to remind you of, though, to help you get started here, is looking up at these constraints. Each cat pen is going to require how much space?
6.
6 square feet, right? So let's say you have 2 cat pens. How much space is that? 12 and 3.
24. Oh, snap.
How much would it be?
24.
Not 24.
You just said 2. I mean, you just said 3.
Uh-huh.
Oh,
18.
Oh, yeah, true, it's about 6. It's about 6.
There we go. So notice, what are you repeatedly doing?
Multiplying.
Not repeatedly multiplying. You're repeatedly adding, so could you multiply to make this a little bit easier? Okay, so that's something to consider. When it comes to the dog runs, if you have 1 dog run, how much space would that be?
24 square feet.
24 square feet. But let's say you jump up to 6 dog runs. How are you going to figure out how much space that is for 6 dogs?
24 square feet times 6.
24 times 6. So notice you're repeatedly adding 24 6 times. Those are things to think about here with the startup cost as well. I want you to take 3 minutes on your own without talking to your small group, and I want you to try to come up with a combination or a couple combinations of cats and dogs that satisfy the constraints, and figure out how much money they would make from that. Notice you have some starting options or ideas right here. So 3 minutes thinking on your own. Which also means you may want to be writing stuff down.